Hey guys, this is Mr. Grice for Algebra 2, Chapter 3.1-3.6 review, number 1. Remember to show all your work and to write your answers on the lines. Okay, so we're going to go ahead and get started with number 1. Now, you guys might think, oh look, there's a fraction right there. I should multiply everything by 4. No. We're only going to do that with problems like number 4 when there are multiple fractions. Okay? When there's just one fraction, we're going to solve this using SNAPMap. Okay? So I notice where my x is. I want to get the x by itself. So the first thing that I'm going to do is get rid of that 5. Now, it's a positive 5. I know there's a subtraction sign right there, but that belongs to the 3/4. So it's a positive 5. I'm going to do the inverse, which is subtract. So I have a negative 3/4 x equaling 14 minus 5 is 9. Okay, so now I want to get rid of a fraction. Now, to get rid of a fraction, I need to multiply by the reciprocal. Okay, and what I do to one side, I have to do to the other. My fractions cancel, the variable's all by itself. Now, on the right-hand or left-hand side over here, I'm going to multiply 9 over 1 times negative 4 over 3. Now there's multiple ways that we can do this. I'm just going to multiply straight across and get negative 36, because 9 times 4 is 36, 1 times 3 is 3. And then I'm going to divide that. Negative 36 divided by 3 gives me a negative 12. So I know that x equals a negative 12. And just like the directions say, I'm going to write my final answer on the line. Okay, number 2. So once again, I'm going to draw my line down the middle. The first thing that I notice is that I have the parentheses and I need to distribute the 2 inside. 2 times m is 2m and 2 times 7 is 14. And that's the only thing that changes. Now, the next thing to do is to combine like terms. I'm going to look on both sides. So 2 plus 4, that is a 4, gives us 6m minus 14. Now, let's look at the right side. I have 7m minus m, which gives us 6m. Okay, so the next thing to do would get my variables to one side, so I would subtract the 6m. Well, the 6m's cancel on both sides, and I'm left with a negative 14 equals 8. So, does negative 14 equal 8? No, it doesn't. So that's not my answer. My answer is no solution. Okay? All right, number 3. Now, number 3 we can do a couple different ways because you guys have calculators now, right? But I know a lot of people hate working with decimals, so we're going to solve it by getting rid of the decimals. Now, I want to look to see how many numbers are behind the decimal, and there are 2 numbers behind the decimal, which means my number needs to have 2 zeros. So I'm going to multiply by 100. So that turns into a 1y. And remember, I have to multiply everything by 100, not just the decimals. Okay, so far we have 1y minus 300 plus 2y equals, and I have to keep multiplying. 100 times negative 1 is negative 100. That turns into plus 3y. And then 100 times negative 2 gives me negative 200. Okay, and now the next thing I'm doing is I'm looking for like terms on the left side. 1 plus 2 gives us 3y minus 300. And on the right side, I have negative 100 minus 200. When I combine like terms, I get negative 300. Okay, and just like problem number 2, I need to get my variable to one side, so I'm going to subtract the 3y. And when I subtract the 3y, they end up canceling, and we're left with negative 3y, or negative 300 equals negative 300. And that's a true statement. So when I'm left with a true statement, it means my answer is infinite solutions. So I can plug in any number I want to, and it'll equal y. Okay, number 4. Now, number 4 is when I want to get rid of the fractions. Okay, so I am going to want to multiply everything. But I need a number that both 2, 3, and 4 go into. All right, so I'm going to list the multiples of each number. And I need a number that all of them go into. All right, and the magic number is 12. Now, if you're too lazy and you don't want to write all those down, use a multiplication chart. It'll help you out. Okay, so I'm going to multiply everything by 12 over 1. Okay, so first one is 12 over 1 times 1/2. Multiply straight across, we get 12 over 2, and 12 divided by 2 is 6. So 6x. Now we have 12 over 1 times 3 over 4. We're going to multiply straight across. 12 times 3 is 36. 1 times 4 is 4. And 36 divided by 4 is 9. Okay. And now we have 12 over 1 times 1/3. 12 times 1 is 12. 1 times 3 is 3. 12 divided by 3 is 4. Okay, and the last thing that we're multiplying, 12 over 1 times 1. Oh, we've already done that. That equals 6. Okay, and it's going to be a negative 6. Okay, now that I got all the fractions out of the way, this looks like a pretty simple problem. I want to get my variable to one side, so I'm going to move the smaller variable. 6 minus 4 is 2. And now we solve by SADMAP, which means I subtract the 9 to both sides. We get 2x. Negative 6 minus 9 is a negative 15. And then the last step would be to divide by 2. And since when we divide that, we get a decimal, Ms. Carranza talked about in class how we're going to leave it as a fraction. So we get negative 15 over 2 as our final answer. Okay, number 5. So number 5 wants us to solve for n. So what we're going to do is we are going to use SADMAP. Okay, don't freak out. So the first thing I'm looking for is to cancel addition or subtraction. We have addition, so I'm going to subtract the r to the other side. Now, the n is not by itself yet. To get rid of the 2, I need to divide by 2. Now, in class, we talked about, oh yeah, we can divide everything by 2 if we can't simplify. But we can simplify things here. Okay, so 6 divided by 2 gives us 3m. Now, how many r's do we have? Well, we have one r there. So what that turns out to be is 1/2 r, and that equals n. And now you need to ask yourself, is the n all by itself? Yeah, it is. So n equals 3m minus 1/2 r. All right, number 6. Number 6 is asking us to solve for m. So what we're going to do is we are going to multiply. I'm going to multiply the 3m times 6, and I'm going to set that equal to 5 times 2m plus 1. Okay? Well, 3m times 6 is actually 18m. And then I need to distribute the 5. So 5 times 2 is 10m, and 5 times 1 is 5. And now we're just left with SADMAP. So I'm going to subtract the 10m to both sides. Those cancel. 18 minus 10 is 8. So 8m equals 5. And then to get the m all by itself, I need to divide. So I'm going to divide both sides by 8. And I get that m equals 5/8. I can't reduce the fraction, so I'm just going to leave it as it is. Okay, let's flip it over. So number 7 is asking us to find the missing angles. Okay, we have angle A and then angle B. So on these lines, I'm going to say we need to find the measure of angle A and the measure of angle B, just to remind us. So what do we know about the measure the angles of a triangle? I know if I add up the 3 angles, it's going to equal 180. Now, here's the only question. Do we know what this angle equals right here? Well, yeah, that box means that this is a 90-degree angle. So I can take what's in the yellow, my 2x plus 30. I'm going to add it with our pink angle, which is just x, plus the 90 degrees. And all of that together is going to equal 180. Okay, let's combine our like terms. I have 2x and x, which gives us 3x. And then I have 30 plus 90. 30 plus 90 is 120. Okay, and now we're going to solve using SADMAP, which means I'm going to cancel my addition with subtraction. I get 3x equals 180 minus 120 is 60. And then to get the x all by itself, we're going to divide by 3. And I get that x equals 20, and that's 20 degrees. Now, the nice thing, hey, guess what? That's B. I know right away that the measure of angle B is 20 degrees. Okay, I only know that because, hey, it says it right there, B is 20. Now, the only angle that I need is angle A. So we're going to plug in for x, and I know that x is 20. So 2 times 20 is 40, and 40 plus 30 is 70. And that's going to be 70 degrees. So the measure of angle A, 70 degrees. Okay, last one. Number 8. Our favorite, the word problems. Yeah, word problems with angles. Okay, so let's go ahead and read this. 125 more than 3 times times what? Times the complement of an angle is, it's another keyword right there, twice the supplement of an angle. So, wow, we got a lot of stuff right there. A couple things to remember. Complement means 90 minus x, and supplement means 180 minus x. So if you don't know that, I definitely write that down. Okay, so let's break it down. 125 more than. Well, more than means to add, and that I have to switch the order. Okay, so there's my plus, there's my 125, and now I need to work on 3 times the complement. So I have 3 times, and now I'm just plugging in the complement, okay? It's the 90 minus x. Now we've got that word is. Is means equals. And it equals twice. Twice means multiplication, and I'm multiplying the supplement, which is 180 minus x. Okay, and guess what we do now? That's right, we solve. Okay, so on the left-hand side, we can distribute. 3 times 90 is 270, and 3 times x is 3x. Now, on the right-hand side, once again, we have to distribute. 2 times 180 is 360, and 2 times x is 2x. Okay, next step is to combine our like terms. 270 plus 125 is a positive 395, and that equals 360 minus 2x. Okay, so I have variables on both sides. I want to move the smaller variable, so it looks like it's bigger, it's just the bigger negative. So we have 395 equals 360, and negative 2 plus 3 is actually just positive x. Now the last step to get the variable by itself is to get rid of this 360. It's positive, so I'm going to subtract. 395 minus 360 gives us 35. So 35 equals x, and that's going to be 35 degrees because we're talking about an angle. Okay, well that's going to be it for Algebra 2, Chapter 3.1 through 3.6 review number 1. Now, if you need help on review number 2, there's going to be another video for that. So this is Mr. Grice signing off. Thanks for watching.